your API might be sending 10 times more data than it needs to. Response compression is when the server shrinks its response body before sending it over the network. The server applies a compression algorithm, gzip, deflate, or Brotli, reducing the payload size significantly. The client then decompresses the data on arrival. A 1 megabyte JSON payload can shrink to under 100 kilobytes. That's a 90% reduction. The client and server negotiate compression through two HTTP headers. When making a request, the client includes an Accept-Encoding header listing the algorithms it supports, like gzip and Brotli. If the server compresses the response, it signals which algorithm it used via the Content-Encoding response header. The benefits are significant. Smaller payloads mean less bandwidth consumed, faster transfers, especially critical on mobile connections, and lower infrastructure costs. For high-traffic APIs, the savings can be dramatic, making compression one of the easiest performance wins available. Compression isn't always the right call. The server spends CPU cycles compressing data, and the client spends cycles decompressing it. So for very small responses, the overhead outweighs the benefit. Compression also provides no advantage for already compressed content like JPEG images, video files, or zip archives, since these formats can't be compressed further. Response compression uses gzip or Brotli to shrink API payloads, saving bandwidth and improving speed. Follow for more REST API essentials. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.